Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic Design of Experiments. And in Design of Experiments, we are seeing the problems on one-way ANOVA classification. In the previous video, we have seen a problem regarding it, and another type of problem can be viewed in this video also. The problem goes like three different machines are used for protection on the basis of outputs. Of one-way classification, we are going to test whether the machines are equally effective. This is what we are going to test. This is a key point here. Test whether the machines are equally effective or not. We are given with the data for machine 1, 2, 1, 3, and also you are given with the data for the tabulated value also. We need not check on for the table value. So as always, we will be starting with the null hypothesis, which is H0. There is no significant difference between the machines, which means the machines are equally effective. And step 2. What will be our step 2? It is our alternative hypothesis, that is there is significant difference between the the three machines given. This is what our alternative hypothesis is, and as usually we will be framing up table 1. Table 1 is nothing but we are just making the given contents as columns. First machine for x1, second machine for x2, and third machine for x3. All the three are noted here, and for the futuristic purposes we will be calculating x1 square, x2 square, and x3 square. x1, x2, x3 is also calculated here, and all the sum of values, summation of x1, summation of x1 square, summation of x2, summation of x2 square, summation of x3, and summation of x3 square, all the values are calculated in this table itself for futuristic purposes. So now we are moving on to the third step. Third step is nothing but the total number of samples. Total number of samples is 12, as obviously seen from the given data, and see the total number of machines. It is also obviously given as 3. And in step number 4, what we will do, we will be calculating T, which is summation or sum of the given contents, which is summation of x1 plus summation of x2 plus summation of x3. Therefore, T is equal to 143. And then the very important thing is to find the correction factor. What is the correction factor? CF is equal to T squared by N. CF is equal to T squared by N. 143 the squared by N, which will be giving the correction factor as 1704.08. Step number 6, what we will be finding? We will be finding SST, sum of the squares of the treatments, which is nothing but all the treatments minus the correction factor. All the treatments minus the correction factor here. The correction factor is a very important concept which should not be ignored, otherwise there will be errors occurring. Which is the SST will be given by 284.92. And what is SSC? SSC is the sum of the squares of the given contents as per the data. Summation of x1 squared by n1 plus summation of x2 squared by n2 plus summation of x3 squared by n3 minus the correction factor. Here also we should note that the correction factor is a very important thing to do with the error concept. And later we have also seen SSC to be 162.17 and SST to be 284.92. In step number 8, we are going to find MSC, and step number 9, we are going to find SSE, and in step number 10, we are going to find MSC. All these formula have been learnt already. MSC is SSC by C minus 1, SSE is SST minus SSC, and MSE is SSC by N minus C. This is nothing but the degrees of freedom, which is 1. C minus 1 is degrees of freedom for columns, and N minus C is the degrees of freedom for the errors. So this is what we have done, and we have calculated all the required values like these things for the ANOVA table. And the next step, what we will do, we will frame the ANOVA table. In the columns, we will be having sources of variation, degrees of freedom, sum of the squares, mean sum of the squares, variance ratio, which is F calculated, and the table value, which is F tabulated. So in the first column, we will be having between the columns and between the errors, because it is a one-way ANOVA classification. And degrees of freedom is C minus 1 for column and N minus C for errors. Sum of the squares is SSC. From the steps we have calculated or written down the value here. SSE is 122.75. MSC is calculated, is taken up from the procedure followed, steps followed, 81.085, and MSE is 13.65. Which one is bigger? We note that MSE is bigger. Therefore, MSC by MSE, which is equal to 5.95. Therefore, the calculated value is 5.95. And the tabulated value is 4.26, which is given actually in the question. So on comparing, we can note that this is greater. Which one is greater? F calculated is greater than the tabulated value. Therefore, what we will conclude, if our calculated value is greater than the tabulated value, we will note that there is some sort of a discrepancy over the given data, and therefore we reject the null hypothesis H0, and therefore the three machines are not equally effective. As our important conclusion given here. In the previous problem, we note that we accepted the H0, and this problem we are rejecting the null hypothesis H0. So this is how we perform a one-way ANOVA classification problems. We will have some more videos on the next classes as well. Thank you.